Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like and appreciate what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way of helping me promote my channel, and that's also makes me inspired, refreshed, and keeps me going. Now, if you find my videos interesting to your studies, also please don't forget to subscribe. Analyze the frame shown by slope deflection equations, then construct the shear force and bending moment diagrams, as well as sketch the elastic curve. E is constant. So here is the given frame. So it will undergo sidesway. Let's assume that the uh, sidesway is rightward as shown in the figure. So we'll call this delta. And for BC, this vertical movement here, and for CD, this one. So let's enlarge that triangle. Remember that if we call this angle theta, then the angle between the vertical and the normal to the sloping side of this frame is also theta. So this is normal, the blue one, delta CD, and the vertical is theta. So this is delta CD, delta BC, and this is delta for AB. So this angle is theta. So call that theta, delta BC, delta CD. And in this triangle here, opposite to theta is 8, adjacent to theta is 3, and the hypotenuse is square root of 8 square plus 3 square, that is square root of 73. So by similar triangles, delta as to 8 equals delta BC as to 3 equals delta CD as to square root of 73. Therefore, delta BC is 3/8 of delta, while delta CD is square root of 73 of delta over 8. So we now establish the first equation, moment AB is equal to 2 times EI 2 over 8, quantity 2 times 0 plus theta B minus 3 times delta over 8. Simplifying, MAB is 0.5 theta B minus 3 delta over 16. Call that equation 1. So MBA is, so since theta B is doubled in this equation, so this becomes theta B then minus 3 delta over 16. So theta B minus 3 delta over 16, call that equation 2. So MBC, take note there is a load, so there is fixed moment, negative WL square, W times 6 square over 12. And since EI is treated 1, MBC is 2 times 1 over 6, quantity 2 theta B plus theta C minus 3 times delta BC is negative. The chord joining B and C rotates counterclockwise. So negative 3 delta over 8 over length 6, then minus 36 square over 12. Simplifying, MBC is equal to 2/3 theta B plus theta C over 3 plus delta over 16 minus 90. Call that equation 3. Then for MCB, interchange coefficient, copy, and by symmetry, this is positive 90 because the loading is rectangular and it is across the entire span of BC. So theta B over 3 plus 2/3 theta C plus delta over 16 plus 90. Call that equation 4. Then MCD, rotation is clockwise. So 2 times EI 1.5 over L square root of 73, quantity 2 theta C plus theta D, 0 minus 3 times square root of 73 delta over 8 over square root of 73. There's no loading, so no fixed moment. MCD therefore is 6 theta c over square root of 73 minus 9 delta over 8 square root of 73. Call that equation 5. MDC, since it is theta d which is 0, is doubled, so half of theta c, so this becomes 3. MDC equals 3 theta c over square root of 73 minus 9 delta over 8 square root of 73. Call that equation 6. Then by equilibrium equation at joint B, MBA plus MBC equals 0. So theta B minus 3 delta over 16 plus 2/3 theta B plus theta C over 3 plus delta over 16 minus 90 equals 0. Combine like terms, simplify, and set up equation A. So 5/3 theta B plus theta C over 3 minus delta over 16 equals 90. Call that equation A. At C, MCB, this plus MCD, this equals 0. So theta B over 3 plus 2/3 theta C plus delta over 16 plus 90. Then plus 6 over 6 theta C over square root 73 minus 9 delta over 8 square root 73 equals 0. Simplifying, combining like terms. So theta B over 3 plus 1.3689 theta C minus 0.06917 delta equals negative 90. Equation B. Then we establish another equation because there are 3 unknowns in these equations here, and that is based on the free body diagram of this entire section. Let's extend this sloping end and this end to find the point of intersection between those legs, and we'll call that YZ. And let's apply the shear, normal, and moments at A, B, and C. So Y as to 8 by similar triangles to this, Y, then Y vertical, this is 8, equals Z hypotenuse over square root of 73, the length of this sloping end, then equals 6 meters as to 3. So Y is 16 and Z is 2 square root of 73 meters. So this is square root of 73, this is 2 square root of 73, so the distance from O to D is 3 square root of 73. This is 8, this is 16, double of 8, so supposedly this is 24. And apply the shear, normal, and moment. Let's assume moments to be clockwise. Here also, normal to D, shear D, then moment DC. So summation moment O equals 0. Then we have V sub A times 8 plus 16 plus V sub D times 3 square root of 73 as mentioned earlier. Then plus 50 times Y, 50 times 16, minus moment of this load 30 times 6 times 3. So we take note summation moment O. Then equals clockwise moments MAB and MDC. This is also clockwise, so it is supposed to be put there, but just make it in the left side. So VA is 1/8 of MAB plus MBA based on this free body diagram. Summation moment C equals 0. VA times 8 equals MAB plus MBA. So therefore VA is 1/8 of MAB plus MBA. Then for this sloping part, summation moment about C equals 0. V sub D times square root of 73 equals MDC plus MCD. So therefore V sub D is 1 over square root of 73 of MDC plus MCD. So 1/8 of MAB plus MBA times 24 plus 1 over square root of 73 of MDC plus MCD times 3 over 3 square root of 73, then equals, so simplifying this, negative 260 plus MAB plus MDC. So we will have this equation on the next slide. We ran out of space here. So from the results earlier, these are the moments A, B, B, A, C, D, DC, and these were the established equations, two equations. Let's have the equation we established in the last part of the preceding slide. 1/8 of MAB plus MBA times 24, 1 over square root of 73 of MDC plus MCD times 3 square root of 73 equals negative 260 plus MAB plus MDC. So combining like terms, simplifying, we have 2MAB plus 3MBA plus 2MDC plus 3MCD equals negative 260. So MAB is this one. So 2 times 0.5 theta B minus 3 delta over 16 plus 3 times quantity theta B minus 3 delta over 16 plus 2 times 3 theta C over square root 73 minus 9 delta over 8 square root of 73 and plus 3 times quantity 6 theta C over square root 73 minus 9 delta over 8 square root of 73 equals negative 260. So theta B, 2 times 0.5 theta B plus 3 theta B. So we combine like terms here, theta C and delta. And simplifying, we have 4 theta B plus 24 over square root of 73 theta C minus 1.5959 delta equals negative 260. Call that equation C. Then we solve simultaneously equations A, B, and C to get theta B equals 87.777 over EI. Theta C is negative 74.387 over EI. Then the delta equals 251.992 over EI. So computing MAB, 0.5 of 87.77 minus 3 times 251.992 over 16. So MAB equals negative 3.360 kilonewton meter. MBA is theta B, 87.777 minus 3 times delta over 16. So MBA is 40.528 kilonewton meter. Therefore, MBC is negative 40.528 kilonewton meter. MCD 6 times negative 74.387 over square root of 73 minus 9 times 251.992 over 8 square root of 73. MCD is equal to negative 85.418 kilonewton meter. Therefore, MCB is positive 85.418 kilonewton meter. Then MDC, 3 times theta C, negative 74.87 over square root of 73 minus 9 times 251.992 over 8 square root of 73. So MDC is equal to negative 59.299 kilonewton meter. So having found this, we can compute shear at A, and these are the directions. Then for BC, directions, and for D, these are the directions and the directions of the moments based on the results here by slope deflection equation. So VA is equal to 1 over 8 of MAB, which is negative 3.36. Then MBA, 40.528. Shear at A, therefore, is 4.646 kilonewtons rightward. Then at D, B just to the right, so considering this summation moment C, so shear at B just to the right times 6 plus MCB, which is 85.418, equals MBC, 40.528 plus moment of the load 30 times 6 times 3. So shear at B just to the right is 82.518 kilonewtons. So take note, it is also the value of AY here. Then shear C left times 6 plus MBC 40.528 MBC equals MCB 85.418 plus moment of the load 30 times 6 times 3. So shear at C just to the left is equal to 97.482 kilonewtons. Then shear D time is 1 over square root of 73 of MDC, which is 59.299 plus MCD, which is 85.418. So shear at D is 16.938 kilonewtons and in that direction there. So our top fiber is left top and right of these segments of the frame. So we now have this on the next slide for our sketching of shear force diagram and the bending moment diagram, as well as the sketching of the elastic curve. So this is the figure, then these are the results. So we begin with the shear force diagram first. VA, so 4.646 negative, then constant, it should close there. Then for shear B just to the right, 82.518, then minus 30 times 6 is negative 97.482. Shear C right, that's fine. Then this distance is 82.518 divided by 30, or you can solve that by similar triangles. So this is 6 minus 2.7506, 3.2494 meters. Then on this face, we begin with positive 16.938, and constant, it should close here. So this is the shear force diagram in kilonewtons. For the bending moment diagram, so moment AB is negative since this is the top fiber. So we have negative 3.36. Then minus the area, 4.646 times 8. Then we have straight line negative 40.528. It's correct. So close there. So it should start with negative 40.528. Then plus the area, 1/2 of 2.7506 times 82.512, positive decreasing. Then this is equal to 72.959. 72.959 minus this area minus 1/2 of 3.2494 times 97.482, negative increasing. So it should be 85.418. So negative 85.42, that's fine. So it should start here with negative 85.418. Then plus the area 16.938 times square root of 73. The length here is square root of 73. Then we'll have 59.3. Expected 59.299. So that's fine. So it closes there. So this is the bending moment diagram in kilonewton meter. Finally, for the elastic curve, based on this diagram, so negative, so it is concave down, then concave up, then down. Since this is negative moment, concave down, then positive, concave up somewhere here. So that's the curvature. So this is the elastic curve expected. So that's it. And I hope that you were able to follow the solutions, the explanations, and the equations, and the construction of the shear force with the moment diagram and the elastic curve.